This week, hundreds of small earthquakes have been detected at Mount Rainier, and this is the largest swarm of quakes.
No reason to raise alarm bells. Seismologists say this is something they're closely monitoring.
Deep beneath the snow-clad summit of Mount Rainier, a mountain both majestic and dangerous, a new warning sign has emerged that has startled the scientific community and captured the attention of millions. Geologists monitoring the stratovolcano have issued a red alert after a network of cracks began to appear beneath its surface. An unsettling development that signals mounting instability within one of North America's most hazardous volcanic giants. Mount Rainier, towering more than 14,400 feet above Washington state, has long been regarded as both a scenic wonder and a looming geological threat. The appearance of fractures beneath its slopes now raises profound questions about what is stirring deep within, and what such changes may ultimately unleash. Before we start, smash the like and subscribe buttons for more updates. The presence of cracks beneath a stratovolcano is never a trivial matter. These fissures suggest the movement of subterranean forces powerful enough to warp rock, deform soil, and strain the very skeleton of the mountain. At Rainier, this is especially concerning because the volcano is draped in immense glaciers, storing more ice than any other peak in the contiguous United States. When cracks open beneath such a volatile environment, the implications extend far beyond a simple surface fracture. They point to stress changes likely caused by magma intrusion, pressurization of hydrothermal systems, or both. Each possibility carries the potential for cascading hazards, from violent eruptions to devastating lahars, massive slurries of mud and ice that can barrel down valleys at speeds faster than a person can run. Geologists, trained to read the subtle language of mountains, interpret these cracks as early signals of instability. Mount Rainier has not erupted in centuries, but its silence is deceptive. Unlike dormant peaks, it remains very much alive, its deep magma chambers still restless. The red alert designation, rarely invoked, indicates that something significant is happening below. When pressure builds underground, it often seeks release by fracturing rock along paths of least resistance. The cracks beneath Rainier are likely such escape valves, cracks that may either relieve stress harmlessly or become conduits for something far more explosive. The scale of Rainier's hazard makes the situation even more precarious. It looms over densely populated regions, with Seattle, Tacoma, and dozens of smaller towns lying within its shadow. The mountain's past has been marked not just by eruptions, but by catastrophic collapses that sent walls of mud racing across the land, burying entire valleys. Scientists know from the geological record that Rainier has unleashed colossal lahars, some reaching as far as the Puget Sound. In a modern context, such an event would be catastrophic, threatening hundreds of thousands of lives and crippling infrastructure across the Pacific Northwest. When new cracks appear, the memory of those ancient disasters rises again, reminding all who live nearby that Rainier is not merely a mountain, but a sleeping giant. Beneath the crust, the processes leading to such fracturing are complex. Magma, less dense than surrounding rock, pushes upward with relentless force. As it intrudes into the mountain's roots, it pries open fractures, heating groundwater and destabilizing rock layers already stressed by glaciers' immense weight. In Rainier's case, the interaction between magma and ice magnifies risk dramatically. A sudden surge of heat could melt vast volumes of glacial ice, triggering floods and landslides even without a full eruption. Thus, when geologists detect cracks, they are not only concerned about molten rock reaching the surface, but also about the cascade of secondary hazards that may be triggered long before a fiery outburst. The decision to issue a red alert is never taken lightly. Monitoring systems on Rainier include seismic stations, GPS sensors, gas analyzers, and thermal imaging, all working to detect subtle changes in the volcano's behavior. The cracks are not just visible fractures, but are linked to anomalies in seismic activity and ground deformation that suggest pressurization. Tiny earthquakes ripple beneath the mountain as rock shifts and breaks under strain. GPS receivers record slight but measurable bulges on the slopes, signs that magma may be accumulating. Together, these indicators have painted a picture alarming enough for scientists to raise the warning level. It is a call to readiness, an acknowledgement that the mountain has entered a phase of heightened activity. Rainier's immense ice cloak amplifies the consequences of even minor disturbances. Cracks beneath the volcano's surface may undermine glacial stability, destabilizing slopes that could give way without warning. Such collapses, mixing ice, rock, and debris, can transform instantly into lahars that roar down river valleys. The Puyallup and Nisqually rivers, fed by glaciers from Rainier, carve paths directly into populated areas. Communities along these valleys sit in zones mapped as lahar danger areas, where sirens and evacuation routes already exist in preparation for the day Rainier stirs again. For residents, the news of fractures beneath the mountain is more than geological detail. It is a reminder that their safety is entwined with the moods of this towering volcano. Scientists emphasize that cracks alone do not guarantee an imminent eruption. Volcanoes often display warning signs that may last for months or even years before any major event occurs. Still, the significance lies in the fact that Rainier is now signaling stress in ways that cannot be ignored. Each fracture adds another piece to the puzzle, suggesting pathways magma may exploit or weaknesses in the mountain's structure that could fail. The red alert ensures that both authorities and citizens are reminded of the urgency of preparedness. Evacuation drills, hazard mapping, and continuous monitoring all hinge on understanding these cracks as more than random blemishes. They are the fingerprints of deep forces shaping the mountain's future. The psychological impact of such warnings is also profound. Mount Rainier is not only a volcano but also a symbol of the Pacific Northwest, its snow-capped silhouette a familiar sight from countless towns and cities. For many, it embodies beauty and stability, a permanent presence on the horizon. To be reminded that this same mountain is fractured from within, restless and capable of destruction, can be deeply unsettling. It challenges the illusion of permanence, confronting communities with the reality that the ground beneath them is dynamic and unstable. Red alerts serve as stark reminders that beneath the calm exterior lies a power capable of reshaping landscapes in moments. For geologists, the cracks represent both a challenge and an opportunity. They provide a rare glimpse into the evolving dynamics of one of the world's most closely watched volcanoes. Each new fracture adds data, helping refine models that predict how and when eruptions occur. The more is understood about Rainier's internal plumbing system, the better the chance of giving timely warnings in the future. Instruments will continue to track the expansion of these cracks, measuring whether they grow, shift, or stabilize. Gas samples taken from vents may reveal whether fresh magma is rising, carrying volatile compounds to the surface. Thermal cameras may capture subtle heating patterns that betray the migration of molten rock. All these observations feed into a larger picture of a volcano that is no longer in a quiet state. Rainier's history adds weight to the current alert. Although it has not erupted in over a century, its record is punctuated by violent events. Approximately 5,600 years ago, one of its largest known eruptions produced lahars that buried valleys under hundreds of feet of debris. Even smaller eruptions in more recent centuries triggered destructive mudflows. The mountain's flanks are riddled with unstable slopes weakened by hydrothermal alteration, where hot fluids circulating through rock transform it into crumbly clay-like material prone to collapse. Cracks appearing in such a fragile environment are particularly concerning, as they may accelerate slope failure and unleash landslides of enormous scale. The red alert thus acknowledges not only the possibility of eruption, but also the myriad ways Rainier can destabilize without warning. While the mountain draws scientific scrutiny, it also forces reflection on human vulnerability. The communities surrounding Rainier live with an unspoken pact. They enjoy the fertile valleys, rivers, and resources provided by the volcano, but they also accept the risks of its eventual awakening. Emergency management agencies continually prepare for scenarios where minutes may separate life from death. Evacuation routes are mapped, lahar sirens tested, and public awareness campaigns conducted. Yet no preparation ever feels fully adequate when faced with the sheer scale of what Rainier could unleash. Cracks beneath the mountain, flagged by geologists, rekindle urgency in these efforts, serving as reminders that vigilance cannot lapse. The global scientific community also watches closely. Volcanologists compare Rainier's activity to other major stratovolcanoes, studying similarities in precursory signs. Lessons learned from Mount St. Helens, which erupted catastrophically in 1980 after weeks of cracking, bulging, and seismic unrest, remain etched in memory. The parallels are unsettling. St. Helens also displayed fractures before its eruption, fractures that foretold the catastrophic collapse of its north flank. Though each volcano is unique, Rainier's current behavior echoes patterns that demand respect. The cracks beneath its surface may or may not culminate in a comparable eruption, but they undeniably signify that the mountain is shifting into a more restless state. The magnitude of potential hazards explains why a red alert is not confined to local significance. The consequences of Rainier's unrest extend nationally. Disruptions to air travel, damage to infrastructure, and displacement of populations would ripple far beyond Washington state. The mountain's glaciers feed rivers crucial to agriculture and hydropower, meaning that destabilization could affect water supplies and energy systems. A major lahar could sever highways and railroads, cutting off critical supply lines across the Northwest. The cracks appearing now may be small in scale, but they represent the initial tremors of forces capable of reshaping not only landscapes, but also economies and lives. As geologists continue their round-the-clock monitoring, one truth becomes clear. Mount Rainier is not inert. Its silence has always been deceptive, a pause in a much longer cycle of activity. The cracks appearing beneath its slopes are reminders that time, pressure, and geology are converging in ways that demand respect. Whether they lead to eruption, collapse, or slow dissipation, their presence underscores the fragile balance upon which human settlements rest. The red alert is not a prophecy of doom, but a clarion call to awareness, preparation, and humility before nature's immense power. The story unfolding at Rainier is both ancient and modern. Ancient because it is the continuation of cycles that have shaped the Pacific Northwest for millennia, with eruptions, lahars, and transformations leaving their marks across valleys and coasts. Modern because humanity now possesses the tools to watch these cycles in real time, to measure and predict with unprecedented precision. Yet even with satellites, sensors, and supercomputers, the cracks beneath Rainier remind us that nature retains its mysteries, revealing them only in fragments and signs that we struggle to interpret. The mountain speaks in tremors and fractures, and we are left to listen, to prepare, and to live in the shadow of its towering uncertainty. Beneath the looming mass of Mount Rainier, the appearance of fresh cracks has done more than spark alarm. It has also unveiled the silent, unseen interplay of forces that operate far below the surface. To expand on the reality of this situation, one must look deeper into the processes of volcanism, the unique structure of Rainier, and the broader implications of such seismic unrest on a geological, environmental, and human scale. The red alert issued is not just a technical classification. It represents a decisive moment in the long, tense relationship between people and the restless earth beneath their feet. The cracks that have formed beneath Rainier act like scars on a living body. They are physical manifestations of strain, lines etched into the volcanic edifice as pressure builds from within. For geologists, they serve as windows into the invisible, offering clues about the interplay of molten rock, shifting tectonic plates, and volatile gases. Unlike surface landslides or rockfalls, which can often be explained by weather or erosion, the fractures reported beneath Rainier hint at internal forces reshaping the mountain from the inside. They are not accidental or isolated phenomena. They are part of a larger pattern that speaks of a mountain preparing to alter itself. Mount Rainier is structurally complex, its flanks built from countless layers of hardened lava, ash, and debris from past eruptions. These layers, stacked over hundreds of thousands of years, are not uniform. Some are solid and stable, while others are brittle or porous, prone to collapse when weakened by heat or water. Cracks forming within such a patchwork structure may follow zones of weakness, exploiting seams between layers or faults created by earlier geological events. This structural vulnerability is magnified by the presence of hydrothermal alteration. Hot fluids moving through the mountain chemically transform strong rock into weak clay-like material. When fractures cut through such altered zones, they create potential slip planes for landslides or catastrophic collapses. Understanding these fractures requires attention not only to the mountain itself, but also to the tectonic environment in which Rainier resides. The Cascade Range is born from the collision of the Juan de Fuca plate subducting beneath the North American plate. This ongoing subduction fuels a chain of volcanoes, of which Rainier is among the most formidable. The constant grinding of plates injects magma into the crust, pressurizing volcanic systems and supplying the heat that drives hydrothermal activity. Thus, when cracks appear beneath Rainier, they are not isolated events. They are linked to the restless tectonic theater of the entire Pacific Northwest. For those who live in the region, the concept of cracks beneath the mountain may feel abstract, yet the risks they represent are very tangible. A fracture in Rainier's body is not simply a line in stone. It is a signpost pointing toward potential futures. If magma continues to intrude, these cracks may widen, acting as channels for molten rock to approach the surface. Even if no eruption follows, the opening of such pathways can destabilize glaciers or release floods of meltwater. The immense energy stored in a single cubic kilometer of magma is staggering, and even the faintest suggestion that this energy might be mobilizing demands attention. Beyond the geological perspective lies the environmental dimension. Rainier's ecosystem is intricately tied to its glaciers and rivers, which provide fresh water, shape habitats, and sustain species adapted to the mountain's climate. Cracks beneath the volcano could destabilize ice masses, altering the hydrology of entire valleys. A sudden release of water from beneath fractured glaciers might flood river systems, displacing fish populations and eroding landscapes downstream. For salmon, a species iconic to the Pacific Northwest, such disruptions could devastate spawning grounds, compounding pressures already caused by human activity and climate change. Thus, a fracture beneath Rainier resonates not only with volcanic hazard, but also with ecological fragility. The cracks also hold cultural implications, for Rainier is more than a geological feature, it is sacred to indigenous peoples of the region. Known as Tahoma or Tacubet in native traditions, the mountain has long been revered as a place of power, spirit, and story. Cracks appearing in its body are not merely scientific anomalies, but are imbued with meaning for communities who see the mountain as an ancestor or guardian. The red alert adds urgency not only for scientists and officials, but also for tribal leaders who balance cultural reverence with the realities of hazard. It becomes a moment of dialogue between modern science and ancestral knowledge, both seeking to understand what the mountain is saying. From an engineering standpoint, the cracks beneath Rainier represent a potential nightmare scenario for infrastructure planners. The rivers radiating from the volcano are lined with highways, railroads, and power lines that form the backbone of the region's economy. Ports and airports also lie within the reach of potential lahars, their operations vulnerable to sudden disruption. A lahar sweeping down a valley could erase roads in minutes, isolate communities, and sever vital supply chains. Engineers studying hazard maps know that the cracks beneath Rainier are not just a geological curiosity. They are early warnings that the foundations of modern society could be shaken with little notice. While not guaranteeing eruption, create a psychological shift that transforms drills into preparations and theoretical maps into living plans. For officials, it means reviewing the network of sensors that monitor the mountain, ensuring that communication systems are robust enough to spread warnings within minutes. The cracks are not simply geological, they are catalysts for human action. One striking aspect of Rainier's potential hazard is its invisibility until it manifests. Unlike hurricanes or wildfires, which can often be tracked days in advance, volcanic events can escalate rapidly from warning signs to disaster. The cracks beneath Rainier serve as rare visual and measurable evidence of stress, giving precious time to prepare. They stand as reminders that vigilance is not optional, but essential in the face of such forces. Each new measurement, whether seismic tremor, gas emission, or surface deformation, adds to the evolving narrative of what is happening beneath the peak. The cracks are like lines in a book, chapters of a story still being written by molten rock far below. Looking further into the geological consequences, these fractures may influence how Rainier evolves as a volcano over millennia. Stratovolcanoes grow not just by eruptions, but also by collapse and rebuilding. A crack that weakens a flank may one day lead to massive slope failure, reshaping the mountain entirely. Geologists studying the remnants of past volcanic structures see evidence of such processes. Volcanoes rising, crumbling, and rising again in endless cycles. Rainier's present cracks may be part of a much larger cycle of destruction and renewal, one that will continue long after human civilization has passed. To study them is to witness a process as old as Earth itself, one that unfolds on timescales far longer than human history, yet intersects with it in sudden, violent bursts. The cracks also offer insight into the delicate balance between magma and gas. Magma is not simply molten rock. It is a mixture saturated with volatile gases like water vapor, carbon dioxide, and sulfur dioxide. As magma rises, the pressure drops, allowing these gases to escape. If cracks beneath Rainier connect to rising magma, gas emissions may increase, producing visible plumes or detectable shifts in atmospheric chemistry. Such emissions would not only serve as warning signs, but also influence the local environment, acidifying streams or coating landscapes with sulfur deposits. Monitoring these gases is crucial, for they often reveal more about volcanic potential than the magma itself. A sudden spike in sulfur dioxide, for example, could mean magma is approaching the surface, ready to erupt. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on cracks beneath Mount Rainier? Eruption risk or natural shift? We want to hear from you. Thank you for watching and see you next time.